Last class, I had shared with you all that what is a complex number and the operations which could be applied to the complex numbers. Then I had also talked about the conjugates. Then I had talked about the mod. These are the two things which I had talked about. Today, I'm going to talk about its location. Now, supposingly, if I say that you locate 1, 2, 3, or maybe let's say -5, -6, then you can easily draw a number line and show me the location of it. If this is my 0, you could say this is 1, this is 2, this is 3. And similarly, this side, I'll have my -5, -6. Similarly, the complex number also can be located. Let's see if I have a complex number as 2 plus 3i. Now, you know already that it's a composition of real and imaginary. So therefore, my x is going to be 2 and y is going to be 3. So when I draw a diagram for it, I'll take the help of the coordinate axis. This is my x and this is my y. So this is +2 and +3. So +2 here and 3 here. So I come over here. That means this number of 2 plus 3i is lying in the first quadrant. This is how we are going to talk about it. So now if supposingly this is the particular point I have reached, this is my y and this is my x and this is my, using your Pythagoras theorem, this will give you your mod of z. Now if you remember, mod of z, I had told you it was nothing else but under root of x square plus y square. Now over here, when you talk about the location of the complex number, this mod z will be represented by small letter r. So in your diagram, now we are going to write this, that is r is equal to, and it is this hypotenuse which I am talking about. Okay. Now supposing I give you another z as, let's say, -2 this time and -3i. I've already told you that it has to be written in the x plus iy form. So you are going to write it like this, where you see that your x is -2 and y is -3. So therefore over here now, see, if I have to plot this, I'm going to do it like this. X is -2, that means I come this side, -2 here, and -3, that means going down. So I reach over here. This is -2, -3i as my complex number, and this is going to be my r. So this is my y and this is my x over here. Both of them are negative. So now which quadrant am I? I am in the third quadrant now. So depending on the values of your x and y in the complex number, you are going to locate that particular number over here. Now supposingly, if you write -2, -3i over here, you are going to get a 0. Because the child or the student is expected to recognize what kind of numbers are these. These are negative and you're talking about the x and the y. So therefore, they have to be in that respective correct quadrant only. So complex number, when they are being located, quadrants play a lot of importance. They play a good role in it. Now supposingly I give you another example. Let's say I have -2 this time and +3i. Now let's check this. Where will this go? -2 is over here, all right, on the x, and +3 on the y. So I go up. Now this becomes my new z, that is -2 plus 3i. This is the location. Now this time I have reached where? I am in the second quadrant. So again, I repeat my statement. Depending on the values of x and y, the location of the complex number will be given over here. Now, let's see. I have this as a complex number. Let's say this is z, and this is my y, and this is my x, this is my r, and this is the theta, which, or the angle you could say, which the line is making with the x-axis. If you remember in class 10, when you were talking about the inclination word, you were taught that inclination is the angle between the line and the x-axis in the positive direction. That is how you were defining your theta or the tan theta over there. So therefore, now if I ask you to read, this will be what? Tan alpha can be read as what? You know your trigonometrical ratios, basic ones. So this would be simply y upon x over here. Clear? So now if I'm asking you for the angle between the line and the x-axis, that will be represented by alpha equals to, it's written like this, tan inverse of mod of y upon x. This inverse which I have written over here does not mean 1 upon. This is a way of expressing your angle in terms of the ratio and the sides given to you. That is all. Okay. So therefore, you will study further about this particular term when you go to class 12. Just now remember that alpha over here, or the angle between the line and the x-axis, will be represented by as tan inverse of y by x. Okay, so this is a new thing which we've learned now. Now this, what is this alpha? Let's give it a name. This name is argument. Argument or amplitude. Now see, every time this alpha is not going to be in the first quadrant. So we need to have a specific dimension for it. So therefore now, the principal value, meaning, you can note this down, this is principal value of this alpha which is over here, that will be known as the argument, or that's the correct definition. That's the general statement which you are going to make, or the amplitude. Now, going back to your trigonometry. In your trigonometry chapter, you had this word principal value. What was this principal value talking about? It was talking about a specific range where your angle had to lie, which was termed as the principal value. See, angle round a point, there are 360 degrees, but you cannot name all of them. So a specific range has to be given. So for tan, it was minus pi to theta to positive pi. This is the principal value of theta which you are going to refer to over here in the chapter of the complex number when you talk about the word argument or amplitude. I'll show you just now what this theta will be related to and how it is going to be, affected by the quadrants over here. I'll draw the diagrams for you. But remember that principal value would mean I'm talking about the value of theta ranging between minus pi to pi. We are talking in terms of the tan over here. So therefore now, let's see a diagram. I'm drawing 4 diagrams because I have 4 quadrants, 4 interpretations. So let's see. In the first one, when the complex number lies in the first quadrant over here, that is, the representation is simply x plus iy. Now the diagram would be like this. This is the alpha. Okay. In this now first quadrant, my alpha and theta would be the same thing. All right. So in the positive direction. So here I'm going to say my theta is equal to alpha itself. Only if my complex number, if it is lying in the first quadrant. So whatever alpha you're going to get in your answer, that same alpha would go as a theta over here, and that would be the amplitude or the argument. This is the first diagram. Second one. Now in this time my complex number is lying in the second quadrant. Now the representation of the complex number lying in the second would be minus x plus iy. You can see x is negative, y is positive. So if this is the complex number and I join it to this, then see, this is my alpha, but this is my theta, because what do we say? It is the angle between the line and the x-axis in the positive direction, and this in trigonometry, this is the positive direction, and this is taken as alpha over here. So now see, let me just extend these lines so that you can read clearly. Now in this, see, since my complex number is lying in the second quadrant, theta will be related how? It will be simply, you could say pi minus alpha. This is in the case when I'm talking about the complex number being in the second quadrant. All right. Now, let's see the third one. When my complex number lies in the third, this is my third quadrant. Let's say this is my Z. The representation of this now this time will be what? It will be simply minus x minus iy. This is going to be my complex number lying in the third quadrant. My x is also negative and y is also negative. Now this time see what will be theta? Theta starts from the x-axis, comes over here. This is your theta. But what is your alpha now? Alpha is this. Okay. So now this time the relation between theta and alpha, if you try to express it, then it will be simply what? Theta will be minus of simply pi minus alpha, because in the negative direction it is. All right. So when your complex number is going to lie in the third quadrant, you are going to relate theta and alpha by minus of pi minus alpha. Now, let's see the fourth one. When your complex number lies in the fourth quadrant. Now, fourth quadrant would mean I'm here. So let's see. This representation is going to be how? Positive x, but negative y. I am now in the fourth quadrant. Keep that in mind. This is my z over here. Okay. Now let's look at the angle. Angle would be from here to here. This is my theta. What is alpha going to be now? Alpha is, this is my alpha. So now this time, what will the relation be? Simply theta would be my minus alpha in the negative direction. That is all. So you can now see from the four diagrams over here that wherever your complex number lies, in whichever quadrant, accordingly your theta will be expressed. So you have to remember these four diagrams very, very carefully, learn them up. See the angles, see the lines, and see the quadrants. All these four things have to be kept in mind. Now I'll show you just now how do we apply all this, right? Like say, for example, I have an example. Let's say my complex number is, I'm taking it to be minus 1 plus root 3 and I. First thing is that you read what is your x and what is your y. Your x is what? Minus 1 and y is what? Root 3. All right. So what does this tell you? Where will this complex number lie? If you look at this, it is lying in the second quadrant. From the diagram you can see over here, minus x and plus 1. Now, since you know now where it is lying, all right, let's first calculate alpha. Alpha would be tan inverse of what? Y by x. I've already defined it earlier. So y is what? Root 3. Okay. And x is what? Minus 1. So this comes out to be tan inverse. This will be your root 3. Okay. Now, if I had written it in the original form, I would have read it like this. Tan alpha equals to tan root 3. All right. Now, you know that root 3 is the standard value of tan at the point when alpha is equal to 60 degree. That is pi by 3. So, alpha is coming out to be pi by 3 from your original complex number. But what is your argument or amplitude? I've already told you principal value of this is going to be. Now, this is where your importance of these quadrants come. You have already drawn the conclusion that since it is lying in the second quadrant, how is theta related? Theta is related as pi minus alpha. And you have the value of alpha in hand. So therefore, pi minus pi by 3 gives you 2 pi by 3. This is going to be your amplitude of the complex number given to you as -1 plus I root 3. Right? If you do it step by step, you will never go wrong. Now let's see, I'm presenting another example here. See, I'm taking up this time, changing it. Z is equal to this time. Let me take this minus root 3 this time and minus I. Now, if you read your x and y, what will happen? X is what? Minus root 3. And y is what? Minus 1. So when you look at the values of x and y, where does it take you? Both x and y are negative. That means it is taking you to the third quadrant. So your complex number will lie in the third quadrant. So first let's get alpha. Tan alpha giving you. You've got y by x. Y is -1. X is minus root 3. This gives you 1 by root 3. Okay. Now you know what? 1 by root 3 is the standard value of tan alpha at the point. Alpha is equal to, this is nothing else but tan 30 degrees. That is tan pi by 6. So you can write now alpha directly as pi by 6. You got the value of alpha just now. And you have already told me that the complex number was lying in the second quadrant. So in the third quadrant. Now in the third quadrant, the relationship between theta and alpha is what? Theta is equal to minus pi, put it within the bracket, this. Okay. So now, when you do this, it becomes minus pi plus alpha, which gives you minus pi plus pi by 6, giving you minus 5 pi by 6. This becomes your answer. This is your amplitude or argument given to you for the complex number minus root 3 minus 1i over here. So keep in mind, as soon as you get a complex number, decide its x and y value. Find out the quadrant in which it's going to lie. Second thing. Third thing would be making use of tan alpha, calculate your alpha. And then with respect to the quadrant in which it is lying, alpha, you are going to give the value of the theta. So theta is the actual name of the word argument or amplitude. Alpha is just helping you to calculate the amplitude of this particular complex number. Clear? Now, another important thing which we have to, talk with the help of this diagram only. That is the polar form. Polar form of the complex number, which we are going to talk about. Now see here also. Diagram again is very, very important and very helpful. This is, let's say, my z. I'm taking it to be some x plus iy. And this is my y. This is my x. And this is my r. Which you know now, it is nothing else but mod of z. Which is, mod z is what? Under root of x square plus y square. Clear? Now see. Polar form means you are going to talk about the x and y in terms of the trigonometrical ratios over here. Now let's say this is theta. All right. I can write over here now, see, I know basic trigonometrical ratios. Keep that in mind. Supposingly, if I ask you for cos theta, how will you read it? This is the right angle triangle. So cos theta is what? B by H, right? So therefore, B is what? X. And H is what? R. Now, X can be expressed as R cos theta. So this is one expression for my x coordinate in terms of theta. This is known as the polar coordinate form of the coordinate x. Now, another one. See another ratio now. Sin theta. We know it is what? P by H. P is what? Y. And H is what? R. So this is going to give you Y as R sin theta. This is the polar form of y coordinate in terms of the theta, which has been drawn over here in the given figure on the right side. So you have got the values of x and y, which I've numbered it as 1 and 2, right? These are the polar coordinates. That is why they are written also like this: r cos theta, comma r sin theta. This is the representation of it, basic. Okay. Now, see, z was originally what? X plus I, y. Now, if I substitute for x as r cos theta, I'm going to get this. And similarly for y, if I substitute as r sin theta, I'm going to get r outside and cos theta plus I sin theta. This is the polar form representation now of the complex number. See, here number 1 and number 2 are the coordinates. But over here when I write like this, it becomes a polar form of the complex number. Now this, in short, it's written as R outside, then C for cos, I for imaginary, S for sine, and theta is the angle for both of them. We say R cis theta. So which means cos theta plus I sin theta. Standard form is with the positive only. Keep that in mind. Here also it is with the positive sign. Like in the original form, it is x plus iy. Here also it is with the positive sign only. So now complex number z is equal to x plus iy has been represented in the form of polar form, which is r cos theta plus I sin theta over here. And you must remember r, what is it? R is mod of z, which is nothing else but x square plus y square over here. Okay, so the basic thing which you have to remember now over here is the two trigonometrical ratios, that is sine and cosine. You must remember the basic definition over here. Now let's see how we apply it to a question. I am taking up another example. Let's say, now see, my complex number has been given to me. This is one example which I'm taking up, okay? -1 minus I. Just now it's in the complex number form, right? It has to be changed to polar form. That is my question. Okay, now let's see. Read your x and y. What is x? -1. Y is what? -1. Okay. R now, calculate that. R is mod z, which is going to give you under root of 1 square plus under root this whole thing, giving you again finally root 2. Okay. So now tan alpha is y by x. So therefore, now see, y is what? -1 and x is also -1. This is in the mod. Therefore, this gives me 1. And this is what? You know the standard value of tan 45. That is pi by 4. So you have in hand with you now value of alpha as pi by 4. So now see, with the values of the x and y, you have done so many things. You've calculated r, you've calculated tan alpha, you've calculated your alpha also now. Now let's quickly note. -1 and -1 will take you where? It will take you in the third quadrant. This is my complex number -1 minus I over here. Okay. Now in this, the relationship between theta and alpha was what? Refer to your diagram. Theta was nothing else but minus of pi minus alpha. Clear? So now you could do one thing. Either you could tell me that since Z lies in the third quadrant, therefore theta equals to minus of minus pi minus alpha over here. Or you could simply draw this diagram, show me the location of the complex number, this, all right, and just straight away come onto this line. So you could do it either ways. Now since theta is in the third quadrant over here, so my alpha in hand would be, is given to you as pi by 4, which you've already calculated. So this would be minus pi, all right, I'm opening it up. This is minus pi, alpha is what? Pi by 4, which you simplify. What do you get? You get minus 3 pi by 4. So your theta is minus 3 pi by 4 now, see. Okay, so now complex number. Let's go back to the polar form. It is r, I have learned just now, cos theta plus I sin theta. So therefore now my complex number will be written as r was root 2 cos theta. Theta is what? Minus 3 pi by 4 plus I sin, this is minus 3 pi by 4. Close the bracket. This becomes now your Z in the polar form. This is your form is what? Polar form over here now. Okay. So what is required? You need to read the values of x and y, decide the quadrant, calculate your alpha, and then with respect to the quadrant, correspondingly calculate to the value of the theta and substitute in your value of z, which is to be written as r cos theta plus I sin theta. Clear? Now, I'm taking up another example, little bit more difficult than this. Let's see. This example which I'm taking up is going to revise also in a way everything what you learned yesterday. Now see. Yesterday, I mean in the last class. The complex number is 1 plus 7i upon 2 minus I whole square. Now see, this is my Z. I have already told you that all your complex numbers have to be in the form of a plus ib or x plus iy. So we will have to simplify this further, bring it down to that form and then proceed with the question. I cannot directly start doing it. So therefore, let's see this. 1 plus my numerator remains as such. Denominator will change into 4. Then this will become minus 4i. This will become plus I square. Now I'm not showing you basic form. Directly I'm writing it, the multiplication. So therefore now this turns out to be 1 plus 7i upon. Now see, this will be I square minus 1. 4 minus 1 will give you 3 and minus 4i is already there. Okay. Now again, to reduce the denominator to a single term, I will have to multiply by the conjugate of the denominator. So therefore, multiplication and division by the conjugate of the denominator I'm doing. This is this, conjugate of it. Now, this is going to finally now give me, again, I'm not showing you the multiplication steps, directly writing it. This is going to give you, I will have 3 ones are 3, then I will have plus 28i square, plus I will have 21 and 4, 25 I, plus 25 I upon. Now, in the denominator, difference of 2 squares, so this is going to give me 9 minus 16i square. Clear? This is normal algebraic multiplication which we did last time. Then equals to, now the numerator reduces to, now you can see I have I square over here which will be minus 1. So therefore minus 28 this becomes. 3 minus 28 will give me minus now 25. And plus 25i is already there. Denominator, let's quickly see. Here again I have I square which is now minus 1. So minus 1 into minus 16 gives you positive 16. 16 plus 9 gives you 25. So this is 25. Now when you split this up, it changes to minus 1 plus 1i. Now see, your complex number has been changed to now minus 1 plus I, where your x is minus 1, y is positive 1. Clear? Now, decide upon the quadrant on so quickly. Let's see. I have minus 1 as x, so I'm this side, and positive y, so that means I am in the second quadrant. So this is my z over here. Okay, I'm in the second quadrant. Now let's see. I have my x value with me. I have my y value with me. So I'm going to first calculate my r. That is under root of minus 1 square plus 1 square. That again turns out to be root 2 only. Okay. Now, tan alpha. Tan alpha is y by x. That is y is what? 1. And x is minus 1. This gives you 1. So therefore, now this is at the point again. Tan 45. That is tan pi by 4. So that means alpha is nothing else but pi by 4 over here. Now this, you have calculated r, you have calculated your alpha, you have decided upon the quadrant also. Since now again, since z lies in second quadrant, right? Theta will be what? Simply pi minus alpha. Okay, so therefore now, if you refer to your diagram, let's quickly check that. Second quadrant meant what? I was in the, here I was, this diagram. So theta is equal to pi minus alpha. So see, if you just learn up the diagram clearly, you will get the answer always. So theta is equal to pi minus alpha over here. Now, pi is pi, alpha is pi by 4, and you get 3 pi by 4. This is your theta over here. So now, if I have to write my z, which was given to me as 1 plus 7i. Now see, I'm not writing the simplified version of it. I'm writing the original complex number which was given to me over here. So this will be expressed as root 2, and this will be r cos theta would be cos 3 pi by 4 plus I sine 3 pi by 4. This becomes your complex number in the polar form. R is there, theta is there, and the two ratios are there. And in the middle, I have the positive sign. This is in the standard form of my representation over here of the complex number in the polar form over here. All right. Now, one more conclusion which we could have drawn over here. See, we have learned just now that x is equal to r cos theta. All right. When we started the lesson, this is another concept which we can derive. Y is r sine theta. Okay. Then, if you square up both these statements, all right, what will happen? X square equals to r square cos square theta. Similarly, the second one, y square giving you r square sine square theta. And if you add these up together, right, what will you get? X square plus y square giving you r square times of cos square theta plus sine square theta. And you know that this is 1. So you can say x square plus y square giving you r square into 1, which is r square. Okay. So now you can read the value of r also over here. That is under root of x square plus y square. Clear? Now see, you have one proof there, which I did in the earlier, as when I started the lesson. Second proof I've given you here, that mod of z can be calculated even in the polar form also, when you have the values. Similarly, now see, if I divide 2 by 1, what will happen? See, y upon x equals to r sine theta upon r cos theta. Now r gets cancelled off. What is this? Tan theta. Clear? So you can now see, decide from here also that your theta is the alpha which we were talking about is nothing else but your tan inverse of y by x. This is your theta over here. Clear? This was something extra which I just told you so that you could, have this knowledge or this information also, that you can calculate your alpha as well as your mod z even with the help of polar form of the coordinates also. Okay. Now let's see another question before we end. There is a question now. Let's see. The question says it's an very elementary question which could be asked for 1 mark. It says mod of z equals to 1 is what type of equation? All right. Question is that what does this represent over here? Now see, you already know that z is equal to x plus I y. Okay. And you also know the definition also. So therefore, this is what? Nothing else but x square y plus y square under the root giving you 1. When you square both the sides, you get x square plus y square giving you 1 over here. Clear?